All right, today we are going to look at absolute value equations and inequalities, and we're going to solve them. So really basic definition, absolute value, remember, is a distance from 0. So absolute value of 6 is 6. Absolute value of any negative number will be positive, so absolute value of negative 12 is positive 12. And then we can have absolute value of variables equaling a number. So if my absolute value of x is equal to 7, my x value could be positive 7 or it could be negative 7, because the absolute value of 7 is 7, absolute value of negative 7 is 7. That leads us to a really general rule. We can get a little more complicated statements inside our absolute value, but we'll always have two types of answers. Since my answer can be both positive or negative, I have x minus a equals negative k, or x minus a equals positive k. So these are our two rules that we will use when we go to solve these equations. So let's look at an example. If we have absolute value of x minus 6 equals 4, we have two options. We have a positive answer and a negative answer. So I start by taking away my absolute values. X minus 6 equals 4. Or I can have a negative answer. So x minus 6 equals negative 4. We solve both of these like a regular equation, add 6 to both sides, and we get x equals 10 or x equals 2. When we get our answers, though, we have to plug them back in so that we check for our extraneous solutions. Extraneous solutions means when I plug them in, they don't work in my original problem. So let's plug 10 in. I have absolute value of 10 minus 6 is absolute value of 4, which is indeed 4. Likewise, if you plug 2 in, we get a solution as well. Here's another example. This time we have something outside of our absolute value, and we absolutely must get this absolute value by itself before we can write our two equations. So I'm going to start by adding this 5, and now my absolute value equation looks something like this. This is where I break it down because my absolute value is by itself. So it becomes 2x plus 4 equals 6, or 2x plus 4 equals negative 6. Then solve, like I said, again, per usual, we get x equals 1 or x equals negative 5. Don't forget to plug them in to check for extraneous solutions and plug them into your original equation. Please solve this absolute value equation. Okay, here we have absolute value of 3x plus 5 equals negative 10. You can stop at this statement because we said absolute value is distance from 0, and we know distance can't be negative. So this has no solutions since that solution appears to be negative. Okay, here's another example. Again, start by writing our two equations, Solve them like usual. We get x equals 6 or x equals negative 2. When I go to plug them in, x equals 6 works. However, x equals negative 2, I would get positive 12 equals negative 12, which we know is not accurate. So in this scenario, x equals 6 is a good solution. X equals negative 2 is extraneous. All right, this leads us into absolute value inequalities. So we can have absolute value of x being less than a. This is what we consider a conjunction because of the less than sign. Therefore, our answer or our solution will always be in this form. Similarly, we have absolute value of x can be greater than a, and this is what we call a disjunction. Our answers will always be in the form x is less than negative a or x is greater than a. So we're going to utilize both of these rules in the next coming examples. Absolute value of x minus 5 is less than or equal to 2. Follows our first rule, which is a conjunction. So we know I can write my answer with the negation of that answer, negative 2, less than or equal to x minus 5, less than or equal to 2. Again, that comes from right here. Negate that answer. So we put negative a, negative 2, less than, in this case, less than or equal to that absolute value piece, x minus 5, and then less than or equal to our a value. Okay. We can solve this like a regular inequality. Add 5 to all three sides, and we get 3 is less than or equal to x, less than or equal to 7. And when we have these inequalities, we can graph them on a number line. Any conjunction, the arrows will come together. All right. Just like in our equations, we had to get our absolute value by itself. We have to do that here as well. So I'm going to subtract 4 to get here. Divide by -2. When I divide by a negative with an inequality, remember my sign has to change, has to flip. So I have absolute value of 3x is less than or equal to -1. Here again, it's saying my distance is going to be less than -1, which means it has to be negative. And our distance can't be negative, so we have no solution. One final example. Absolute value of 2x minus 5 is greater than 9. This is a disjunction, so we can write our two inequalities. We have 2x minus 5 greater than 9, or 2x minus 5 less than -9. Solve them. Normally, we have x is greater than 7 or x is less than -2, and then I graphed that solution set.